Okay, so I'm going to talk a little bit about these inscribed angles. So this angle right here is an example of just an ordinary inscribed angle. So it goes from K, L, J. And I made this example, where I can change these points, and you'll see how, oops, we can make the circle bigger. And this one is a good example of, see how I can change that angle by moving these around. But notice how if I fix these 2 points, so say I fix K and J, and I leave those exactly where they are. Let me make it more obvious. Okay, so now we have an angle here. This inscribed angle is 59.05, and this program, Geogebra, does, you can set it up where it automatically, and that's what I've done here, it automatically measures this angle KLJ, no matter how I change the points that are involved. So notice how when I'm changing this, you can see that the angle's changing. And when I change J, the angle changes. And if I change the center of the circle, it changes. So let's leave it there. That's okay, that's fine. But now notice that if I leave the center alone and I leave K and J, those 2 points, if I leave them alone, but I move L, watch the angle. See how it doesn't change anywhere I move it along? Let's see if it'll change when I move it over here. It does. So now notice, let's go back to the other side of K. If you look at how the angle is intercepting the circle, it's intercepting the circle at the points K and J. And if we extend these lines, let's do that. This one and this one. If we extend those lines, we can see how it's intercepting the circle, and it forms this arc right here. So I guess we could call this a minor arc between K and J. And no matter where I move this point L, it's always going to intercept the circle at that arc. And so that's why we can use that property that tells us that this angle right here is half the measure of this arc that it intercepts. But you'll notice how earlier it did change when I went past. And that is because now we're intercepting this major arc. Oops. So this angle here, well, now it's the opposite of this. This angle here on this side is going to be half the measure of this larger arc. So it's actually going to get bigger. And you can see that that's actually an obtuse angle, whereas this one was an acute angle. And that makes sense because we're now intercepting this larger arc. So our angle is going to be, still going to be half of this, but that's a much larger arc to take half of. And here's another example of that where I actually fixed these points. So I can't move C and B at all. And you can see that the angle will stay the same. It stays at 71.84, no matter where it is on there. And this is just a special case of that, where I've made F and G be points on the circle at along a diameter. So F and G lie on the diameter that goes through the center E. And you'll notice that whenever you have that, no matter what your triangle looks like up here, it's always going to make a right angle, because it's intercepting the circle at this, and it's cutting the circle in half, really. So then you know that this angle has to be half of this this arc, which is half of 180, which makes it always a 90-degree angle.